Hi, this is a quick rundown on these digital assets to basically perform group expansion. I decided to show all three of them for point, primitive, and edge in one video because they share concepts. So basically, the expansion is, let's say I have a point, and with the asset I can select points around it, and I can keep going, just do several iterations of this. Now, the interesting thing about this collection of assets, I think, is that they offer two ways to go about it. And so the expansion can be broad or can be narrow. And so depending on the element type, a different rule will be applied for broad and for narrow. And so usually the first option in the list will be the broad one, and the second one will be the narrow. As you can see, for example, if I come here and can see, so this is the broad and this is the narrow. Same for the primitive, broad, narrow, and here, broad, narrow. Okay, so let me just quickly explain, give an example of what is this. So for example, here I have a point and I can expand it in a way that it expands to all the points that this point in the center shares a polygon or a primitive with. And so in this case, all these points will be expanded onto. On the other hand, I can expand only to the points that share an edge with the initial point. And so in this case, I have a narrow expansion. And for the primitives, the rule for broad is to basically expand to all the polygons that shares a point with, or for narrow that shares an edge. And for the edge elements, basically the broad is to expand to all the edges that shares a point with, or in this case of the narrow, it's just that shares a polygon with. So let's look into those. So here I have a point group, and I have here the expand point group, and I'm going to select group 1, and let me bring up here this visualizer so we can see the group. So you can see those magenta points here at the tip of the nose here, and this one has nothing going on. So basically I can just increase here the slider. You can see more points being part of the group. If you want to, for example, say get max points, well, you can put here a really high number, because there's while this is a loop, there's a stop condition, and so if everything is filled, the loop is going to stop. So hopefully I don't think you'll have a lot of issues by putting here really big numbers, unless there's some special case that this gets that might have to do all the iterations and not actually doing the operation. But overall, I think you can just put here a big number if you want the maximum number of points, or do like the total expansion, and it will be all right. And so you can expand out, or you can expand in. So in this case, you see that the group sort of disappeared. Right, so it's the same thing for the others, but I can here quickly demonstrate what I was talking about, the expansion modes. So here, if I put 1, you see that from this point, all these other points are selected. But for example, if I select edge, these points here don't get picked up, because they don't share an edge with the initial points. Now, other options here are to output the iterations and the normalized version of that, so that as I do a lot of iterations, I can sort of have a fall off value from those iterations. And so here you can choose the name of the prefix for these attributes, and if I turn them on, you can see fall off iter and fall off u. Right, so, and I can visualize this here by, let's say, putting here this attribute triangle where I have fall off u and fall off iter used on the random and outputting on color. And so you can see as I expand the group, you can see those colors, those sort of like easel lines being formed. And so this can be used to basically create a fall off from a certain point. And so you can use this to sort of like have a sort of a distance, topological distance to things. Now let me show here another thing. So here I have copy to points, and this copy to points is going to use that fall off U, the normalized version. And you can see that since I'm using the normalized version that goes from 0 to 1, here I have a transition in the scale of the sphere. So here I have on P scale the fall off U being used to get this effect where the spheres are most apart from the initial selection, they get smaller. So for example, if I come here and I change, let's say, the initial selection from the nozzle to, let's say, I'm gonna pick here this and deselect this. So now the spheres will be bigger here, right? Great. So let me check here another thing. So now I'm gonna look into primitive. So I can select the group, and if I want to see anything here, I have to create the attribute. So in this case, iteration or normalize is fine because I'm using both. And you can see that I can, for example, have the same effect as before. So I have these sort of like ISO lines being displayed. And I can also change here the shared element, and that will also change how this behaves. Same thing for the expand point. So if I put here in this this narrow mode, you can see that the way the group expands and creates these ISO lines is quite different, right? Okay, let's see the edges. And so here, let me put here. So here I have an edge group, and you can see that as if I select the group and I offset it, you can see the edge group growing. The edge group doesn't have any attributes being outputted because I can't store attributes on edges. I could sort of, I know about ways to sort of get, you know, some randomization on edges and stuff like that, but maybe I'll do a video just for that. So here you can only expand the group, and that's all. And for example, if I apply that to a dissolve, you can see that basically it dissolves the group, the mesh, as the edge group expands. And then lastly, I just wanted to show that this also works on curves. And so, for example, I have here a polygon curve, and I have here, let me select the group. I have here a point group. You can see that these magenta dots in here, in here, and in here. And you can see that if I, for example, if I have the broad group that basically converts to primitive and then from primitive back to points, you can see that this right away selects everything. And I don't want this because, you know, basically I just convert from, I have no crawling going on. I have no expansion going on. Basically, it just selects everything, which can be useful. But in this case, I was looking to have also something that allows me to continuously grow. So for example, here, if I select the edge as the shared element, you can see that I can grow the expansion, and it gradually grows, and up to, you know, up to a point that fills the whole curve. And so that's it. And the same thing for these this edge group, where basically you can see I have here this edge group, and I can expand it. Oh, first I need to select it here, and you can see that it's also expanded on the edge, on the curve. Sorry. In this case, I don't have to select anything because I'm expanding edges, and so they share the same primitive. It's, if I put this or this, is the same. But you can see that this also works on curves, which can be quite nice. So this is it. Let me know if you have some questions, some feature requests. Cheers.